My name is Tony Robalik, and I work for Gradle as an Android engineer. And let's talk about Android build performance. First, I want to give a special thanks to chess.com. They are Gradle Enterprise customers and have graciously permitted us to use their builds as examples in this presentation. It's really great to be able to use real-world, non-trivial examples in the slides that follow. I'll talk more about that project and how it's configured as I get into specific examples. Of course, as we all know, perf matters. Imagine you have a typical small Android team of 10 developers. Each one of them does 50 builds per day. If those builds, on average, take 60 seconds longer than they need to, that's an entire developer day per day wasted building your app. And the real cost is probably higher. If your builds take too long, you mentally check out, you're browsing Reddit, making new Slack emojis. And as important as those things are, there are probably things your team would rather you be doing. So perf really does matter. Before I go into the individual parts of how you can improve your builds, I want to provide some general guidance. First, don't just start making random changes to your build and then running random Gradle tasks and then just see what happens. Think of it more like a science experiment and use a scientific method. Figure out the exact scenario or scenarios that you're interested in, and then formulate your hypotheses, design your experiment, run it, and then observe the results. Maybe you want to speed up the iteration time while changing code in your app module. Or how long does an incremental build take with the change of a single line of code? And that's actually really easy to model with the Gradle Profiler tool. We're all developers here, let's be honest. We don't want to do anything manually. Let's automate this stuff. That's why Gradle built this small tool, which lets you programmatically define the scenarios that you care about. With it, you can define the scenarios, run them, and have the profiler collect statistics from which you can draw reasonable conclusions. You might want to have a configuration scenario as a reasonable approximation for how long your IDE sync ought to take, or see what benefit you might glean from enabling or disabling various Gradle features. Here I've included an example invocation of the tool and some sample scenarios. And this here is literally the contents of a file you would place somewhere on your file system. Try to run this over long lunch or overnight, though, because it will take a while. Like an hour or more. Also, do look at the GitHub repo for this. It has a lot of good documentation. And of course, before we start diving into the deep end on any of this stuff, it's always worth taking the time to update your tools. Take a moment and ensure you're on the latest version of Gradle and the latest version of the Android Gradle plugin. This is the lowest hanging fruit by far. And now I want to take just a moment to talk about JVM tuning. I've seen a lot on Stack Overflow. Someone says, paste these 20 arguments into your Gradle.properties file and you'll be fine. You won't be fine. That doesn't work. You shouldn't do it. Just give the daemon enough heap space and leave the JVM to itself. It's already well optimized. And of course, the value here is only an example. You might find that you need 2 gigs. 4, 6, 8, whatever works for you. Here we have an example of a daemon that needs more heap space. This is nearly 17 seconds spent in garbage collection, or over 8% of total build time. That's way too high, and I have seen higher. You want that to be around 1 or 2%. So if this is your situation, give the daemon more memory, and you should be good to go. This, by the way, is from a build scan, and I'll show you how to create one of these next. So earlier I was talking about using the scientific method for profiling your builds. Let's say that you've done that. You have a bunch of builds, you think they're taking too long, and you know there's a problem. The question is, where is the problem? How do you investigate your performance issues? Well, there are several tools for this, but one of the most user-friendly and insightful is the build scan. Build scans are a persistent record of what happened in a build, and they're shareable. You can easily paste a link to a colleague and say, hey, this was an incremental build, but it took forever, or this failed, and I don't know why. Could you please take a look? It's a great debugging tool and collaboration tool. It also has a big focus on performance. Another benefit is that if you run into any weird issues, it's very easy to take that link and post a note on the Gradle forums, and then we can help you figure it out. Also, Google loves these scans as well, so if you ever find yourself posting an issue on their issue tracker, include a build scan link. That'll really help them with debugging the problem and fixing bugs in the Android plugin. It's really one of the best things that you can send to us. And of course, build scans are completely free. If you've never used scans before, it's very easy to create your first. So just run any build from the command line and add --scan, and that's it. You can also add this to your build script if you want to have it enabled permanently, but it's a great way to give it a try. Of course, today we're going to focus on the performance aspects of build scans. Gradle has a very high theoretical performance, and the Android plugin itself has many optimizations. My goal today is to help you get closer to that theoretical limit. But of course, Gradle is also very flexible, and there are many opportunities for shooting yourself in the foot, as we all know. Let's go over some of those. These are some red flags you should be looking out for. If startup takes more than 1 second, you have a problem. If a single line change takes almost as long as a clean build, there is definitely something terribly wrong with your build, or you're probably just using an annotation processor. Another very easy benchmark is no change at all. If you run assemble debug and then run it again, that should take almost no time, like on the order of seconds. And of course, high garbage collection time. Beware unmaintained third-party plugins. There be dragons, and they consume all your memory. Yes, yeah, I'll have it up. Now I'm going to talk about your build step by step. The first part of the build is startup, compiling anything you might have in buildSrc and evaluating your settings file. My advice here is short and sweet. You want to use the daemon, you want to make sure it's healthy, and you're not restarting it all the time. The longer it runs, the better and faster your builds will get. Since Gradle is based on the JVM, code needs to be just-in-time compiled. So as you run more builds, the Gradle code gets more and more efficient at processing your build. We have lots of in-memory caches that help us avoid all kinds of file I/O. So if you're not using the daemon, you're paying a really huge price. But of course, the daemon has been enabled by default since Gradle 3.0. You have to be disabling it explicitly, so don't do that. There are many pathologies that I've seen in the settings file. For example, rather than listing all modules explicitly, you might be tempted to do a tree search for any file ending in .gradle and say, these are my modules. That might seem convenient, but it can be hugely inefficient if you have a poorly written search algorithm. You don't want to scan your whole project for those files. And by the way, that block is nonsense, doesn't do anything, don't try it. If you're wondering what buildSrc is, don't worry. I'll go over that in more detail later. Configuration time is a lot more interesting. Many things can go wrong here, and they often do. What is configuration time? It's applying plugins, evaluating build scripts, and running your after evaluate blocks. All these get run with every build, running any task, even syncing Android Studio. So if configuration takes 10 seconds, every single one of your builds will take 10 seconds, even a no-op build. So you really want to get that as low as humanly possible. I'll show you a couple of examples of how that can get out of hand. One of the most common things that you'll see is resolving dependencies during configuration. This is bad because when you're not building anything, you're just running a help task or even just syncing Android Studio, you almost certainly don't want to be resolving these dependencies. You don't need them. So why are you resolving them? And remember that doing this almost always involves network I/O, so you're basically suggesting yourself to the whims of the internet gods at this point. That number there should be 0. Now this is kind of a toy example, but it lets me illustrate an important point. Gradle configures tasks eagerly. It may look like it should be lazy because it's inside of a closure, but everything in there happens during configuration. In particular, that collect call is eager. To properly configure this task, you're forcing Gradle to look at all those files so it can call collect on them. That means it has to resolve all that configuration, all configuration's dependencies, which can involve some network I/O. Luckily, these kinds of things are very easy to fix. You can make them lazy by just wrapping them in a callable. Now we're saying, hey Gradle, I depend on these compiled dependencies when I run. And when I run, give them to me, but not before. Fortunately, we do plan on making this completely illegal in the future, so it will break your builds when you try. You're welcome. However, it's not all about dependency resolution. Let's go a step further and completely avoid configuring a task, unless that is, we want to run it. Here we have a lint task for Kotlin source code. Obviously, we wouldn't be running that on every single build, so why would we configure it on every single build? This register API is for just that use case. Everything inside the curly braces is lazy configuration. The only task that gets configured, it only gets configured when it's actually run. And by the way, this is one of the changes Google's making with Android Gradle plugin 3.3 and above. More and more of their tasks are becoming lazy like this. That's why we're getting faster builds. Another problem is inefficient plugins. Plugins that do expensive operations, expensive computations during configuration. You don't want to do network requests during configuration. I remember this one time, I don't recall which project it was, but I saw a plugin that asked, am I in China or not? The code was, let's ping Twitter, and if we get a response, then we're not in China. The problem was I got the URL wrong. And so they were never in China. And the timeout was 30 seconds. So in every build, they're waiting 30 seconds saying, okay, we're not in China. Let's use the China, sorry, we are in China. Let's use the China mirror for all of our developers around the world. You really don't want to do that. So just use a property for that. Use an export environmental variable. Just do anything but that. Another issue is plugins that do expensive computations. And necessarily so in some cases, but you shouldn't do it too often. One thing that I'll see is a plugin that computes some kind of version from Git, for instance. This script plugin just polls Git and sets the output as your version. It's fine, but then you apply that plugin to every single subproject. And of course, you might be wondering, why worry about this? Git's pretty fast. Why do I care? But there are worse misbehaviors than this. So here what we've done is we apply the plugin only to the root project, and then we inject that value into each subproject. Now we only compute the Git hash once, saving potentially lots of time. There's one more thing to consider for build configuration for Android projects. As you all know, all of our apps come with two configs right out of the box, debug and release. On top of that, we can have flavors, multi-dimensional flavors. When we combine these concepts, we have a variant explosion. I once saw a project with over 100 flavors. Just imagine how many variants that is. And the Android plugin has to configure all of them eagerly at configuration time. We've got dozens, hundreds of tasks are created and configured for each of these variants, and you won't even use most of them. In this example, we imagine that we have free and paid flavors. Obviously, you never released a free version of your app, so you ignore that variant. So that's configuration time in a nutshell. Avoid dependency resolution, avoid I/O, and don't repeat yourself, neither in code nor in build scripts. Let's talk about your own build logic. One thing you want to do is structure your build logic properly. Don't have just one massive script with hundreds or thousands of lines of ad hoc code, ad hoc wiring, and lots of imperative code. One, it's a pain to read. Two, it'll make it hard to diagnose issues. And three, all of your new hires will hate you. You should factor that code out into script plugins. But even better, and what we're moving towards more and more, is extracting things into build source. It has always been a recommendation to extract things into plugins and write proper Java classes when feasible, or Kotlin or Groovy with compile static. This helps keep your build scripts declarative, and by having the plumbing, the imperative code, and a plugin, it makes your project configuration much easier to read and understand. And this has become even easier with a Kotlin DSL and the latest updates to IntelliJ and Android Studio. The advantage of doing this is that it helps that these plugins are compiled statically, which makes your builds run faster. And by the way, if you've never used BuildSource, check out that link. It has very good, easy to read documentation. BuildSource is a great way to make your build better structured and more maintainable. Everything in it can be compiled statically, which improves build performance. Now let's talk about execution time. This is when tasks that you actually select are executed. For example, Gradle clean, Gradle assemble debug. This includes syncing your IDE or running your app from the IDE. Obviously, the IDE uses Gradle under the hood. There are several ways in which Gradle makes this process faster. It executes tasks incrementally. It caches task outputs. And it parallelizes tasks. And we'll look at each in turn. So incremental builds. As I said at the very beginning, if you didn't change anything and ran the same task again, and anything whatsoever is executed, there's a problem. Here I have a timeline of a build from the chess project, and I was just running assemble debug. I hadn't changed anything, and I ran the task again, and a lot of the project reran. 40 seconds is a lot of wasted time to do nothing. So what's going on here? Well, if you look at a build scan timeline, you can click on any task and see a lot of information about it, including why it ran. So let's do that. Here we see that the value for the input property version name has changed for the task generate debug build config. Now, even if you never heard of that task, I know that we all know what it does just from its name. And from its name, we can navigate to the trouble spot immediately. What we have here is someone decided that the version name should be timestamped. Maybe they have a valid reason, but they didn't realize how bad this was from a build performance perspective. So because of this, every build is different. This completely destroys incremental builds. You shouldn't do it. Or if you do, if you must do it only for release builds, not for dev builds. Another very common example is Crashlytics. As you might expect, the Fabric plugin needs a unique ID to enable it to identify each version of your app in the Crashlytics dashboard. By default, it will generate that unique ID for every build, adding tens of seconds to your build time because it basically invalidates a single input file on which many other tasks depend. In this example, I've managed to make a 2-second no-op build take 25 seconds to run. But luckily for us, our build scan clearly shows the culprit. Even more luckily, there's a very easy fix. If you add the highlighted code to your build type debug block, congrats, you just shaved 20 seconds off, or more off your build time. You're now a Gradle Build Ninja. Welcome. By the way, the Crashlytics team is aware of this. We've talked to them. In fact, we found this problem using build scans. They're working on a better solution that's more of a DSL than this kind of crazy hack. But this is safe to put in your code, Stack Overflow-like, just copy and paste. Assuming you use Crashlytics, of course. Gradle provides lots of ways to make compilation faster. We have, for instance, the concept of compile avoidance. For example, let's say we have a change in class. We change a class in project A, and you only change a method body, some implementation detail that isn't exposed anywhere. And you have project B that depends on project A. Project B won't be recompiled because none of the signatures in A have changed. From B's perspective, there's nothing to recompile. Modularization is what enables this compile avoidance. But there's an asterisk here, which is that this works for Java projects, but not for Kotlin projects, for now. That issue right there is, go ahead and like that issue, and maybe JetBrains will give it more attention quickly. There's also incremental compilation. Within a source set, we can tell that you change this file or this upstream class. We can ask which other classes are affected by this, and then we can recompile just those. Let's say you've got class foo, class bar extends from foo. You change foo, bar is recompiled. Incremental compilation just really benefits from nicely decoupled code. If you have spaghetti where everything references everything else, you won't see any benefits from this. And you probably don't deserve them anyway because you're a bad developer. There's an important word of caution. At the moment, Kotlin annotation processors are a little slow. So when possible, use Kotlin language features instead. A good example of this is the auto value library. I used that myself in a project not too long ago. But when I migrated to Kotlin, I was able to drop it in favor of Kotlin's data classes. To give you some numbers, we've got a standard, at Gradle, we've got a standard Java project that we use for benchmarking things. And a clean build takes 30 seconds on this 5 million line of code base. Simply adding the KAPT plugin, kapt, increases build time to 50 seconds. Nothing to process, just adding the plugin did that. So, I love annotation processors. I know that we all do. They help us avoid lots of boilerplate code. But they do come with a price, and you should be aware of that. We are working on this, though. There's nothing inherently wrong with Kotlin that makes this happen. It's just current state of things. For now, one way to help the situation is to modularize your code, which you should be doing anyway. So let's imagine you've got room in your app, the room architectural component. Rather than having it in your app module and applying capt there, put that all into one smaller subproject, and you apply capt just there. So now it only has to analyze a smaller universe of code rather than the entire project that you have. That's one way of sort of mitigating this problem. And of course, there's an elephant in the room. Whenever I say incremental compilation, someone points out that it's deactivated in the presence of any annotation processor. And there's a good reason for that. An annotation processor is just some piece of code It's just some plugin that runs in the compiler. For all we know, it could be formatting your hard drive. But we knew we needed to do something about it. So in Gradle 4.7, we introduced this, added this feature called Incremental Annotation Processing, or INCAP. It's an opt-in for each processor author, a set of rules they need to adhere to. There's no additional API. So long as the processor is well behaved, it can opt into incremental processing. There's a single line of code in a resource file. And I am happy to report that Dagger added support for this recently, in version 2.17, I think. So the future is looking bright for INCAP. However, please be aware that if any single processor in a module is not INCAP compliant, it doesn't work. They all have to opt into this, or you've lost. You should take a look at this issue and check that your favorite processor is on it. We're tracking adoption of INCAP in the Java and Android worlds. Your processor is not on this list, just leave us a comment, we'll add it, and we'll help them become compliant. And I'm also happy to report that in the next several months, build scans will start reporting the amount of time that is spent doing this processing. We hope that you can use this information to make better decisions about your build, and maybe even shame some authors into fixing their code. Okay, let's move on to caching. Caching is basically the next higher level. When you can't run a task incrementally, either because you're in a clean workspace or you've just switched branches, we can still avoid running that task using the build cache. What it does is basically it computes a fingerprint for each task, and when it's going to try to run any cacheable task, it'll look in the cache for that fingerprint. If it finds it, it'll grab that output from the cache and avoid running that task again. It's going to save a lot of time. It's very powerful, and you should know that with each new version of the Android plugin, Google's making more and more tasks cacheable. So if you enable caching in your projects, you'll get more benefit over time. How do you enable it? It's pretty straightforward. Add that to Gradle.properties. If you want to enable it permanently, that'll just be for the local cache, of course. I see photos being taken. I'll wait. Okay. Or on an ad hoc basis with this command line flag. Many tasks are cacheable. Tests can be cacheable. Let's say you've got a 10-minute build, you just ran it on CI and it's green. And you change just one module and you build it again. The 9 other modules that don't depend on that changed module, they don't need to run their tests again, or they shouldn't. Since test input hasn't changed, we can just retrieve the prior test output reports and give them to you, saving potentially a lot of time. And this works perfectly already for Java projects, but we're talking with Google about this, and I fully expect in the near future that Android unit tests and instrumented tests and even parts of lint will be cacheable. This is going to save you a tremendous amount of time, especially on CI. So definitely look into this. For now, though, there are some cases where we don't enable caching for certain tasks. For example, the jar task is actually faster just to run it than pull it from the cache, so we don't bother caching that. And I would be remiss if I didn't talk about remote caching. It's one thing to save time while developing locally, but imagine saving time across your entire team and CI infrastructure. In fact, imagine turning on your computer in the morning, pulling develop, and your first build of the day takes just seconds because someone else has already built all the outputs and they're in the remote cache. Remote cache, they're great. You should be using them already. You can either install one yourself, it's freely available, or use the one that comes bundled with Gradle Enterprise. And then one piece of practical advice, if you're using Kotlin and kapt and the build cache, add this to your root build.gradle file. It will enable the build cache for certain kapt related tasks, improving build performance by a lot, like tens of seconds for a clean build. And last but not least, parallelism. Historically, Gradle comes with the -- parallel flag, and what that does is it tells Gradle that it can assume it's safe to run tasks in different modules in parallel. It's a pretty reasonable assumption for the most part, and it works for most projects, but it's not strictly safe. For example, if you have multiple integration tests in different projects, accessing the same database, basically the same shared mutable state, this won't work. And you shouldn't do that anyway, probably. So you have to know your project pretty well before turning this on, but I still will recommend it. And I'll show you why that is. This is what you'll see in a build scan if parallel is not enabled, or if you have just one app module. In this build, task names have been redacted to protect the guilty. What we see here is a highly linear build where practically all the tasks are run in series. And this is a major red flag. In this next build from the chess project, they have parallel enabled and 16 decoupled modules, and a lot of the tasks are run in parallel. And to give you some more context, this is from a greenfield project replacing a very old code base that had roughly 350,000 lines of mostly Java code. The new project currently stands at about 150,000 lines of mostly Kotlin code, and half of that is in the app module. So it's not perfect, of course, but I think we can agree this is much better than that. One thing to keep your eyes out for is improvements coming soon to the Android Gradle plugin. Right now, there are some Android tasks like resource merging that for now are not well parallelized. But the Android team is changing that pipeline completely, as you probably know, and this should soon show much higher concurrency. All right, let's assume you spent some time optimizing your build. How do you ensure it actually stays optimized? How do you find other issues you might not even know about? That is where Gradle Enterprise comes in. It's a tool that lets you see all the builds that have ever happened in your organization, not just on CI, but also locally. It's searchable, has a nice performance dashboard, and gives you access to a lot of potential insights about how your team is building your apps. You can ask questions like, how long are builds taking? How long is configuration taking? What is the failure rate on CI versus local builds? You know, we expect a lot of failed builds locally. That's just development. Probably not as many on CI. You can see what tasks people are running. Are they running clean too often? That's another red flag because it should not be necessary. That could potentially waste a lot of time. Here I've run a search for local builds where someone has requested clean. I should tell you that at Gradle, it's one of our goals to make so that you never have to run clean, or almost never. And if you do find any issues where only clean will fix, you should email me, and we'll work with you to make that better, because we don't want you doing that. And of course, for every one of those builds, you can click on it and get the deep insights we talked about earlier, and also a really cool performance dashboard. This is actually our own from Gradle just a few months ago. It's something we worried about. Configuration time had gone up like crazy, and we were surprised and not a little worried. But then it turned out that these were from all of the people who were converting Groovy build scripts to Kotlin build scripts. So yeah, if you do that, you're going to expect a lot of churn as we recompile those build scripts. That was normal and expected. But in general, if you see something like this, you might have cause for worry. And you can dig in and see what's going on. You also have an API that you can use to do your own custom analysis. You can set an alarm and post to Slack or something if you hit some metric that you care about. So this is how you can see when something goes wrong and make sure it stays right. And one final thing I wanted to show you that I just discovered last night while preparing for this presentation. All of those spikes are from a single developer on the chess team. It turns out that he's using an old computer with just 4 cores, and it's using the Windows operating system, where everyone else has at least 8 cores. You see how their builds are much faster. So what I've done basically is I've justified to his boss buying him a faster computer. It would double his productivity, I can guarantee it. These are some good resources. I would recommend you guys check these out. You can learn a lot of information about Gradle here. I'll wait. Many photos being taken. One more, I see one more happening. The slides will be online later, of course. Okay. All right. And finally, there's one thing to take away from this talk. Go to scans.gradle.com and start using build scans for your projects. See at a high level what's happening in your builds. And we are constantly improving this, and so the future is bright. Thank you. Are there any questions? Yes, you? Yes. Yes. Oh, the question was, do I feel the same about rebuild as I feel about clean? And yes, a rebuild is just a clean plus a build. So if you have to do that, something is wrong somewhere, some plugin. It could be the Kotlin plugin. It could be something else. But cleaning shouldn't be necessary. The question is, why isn't the build cache enabled by default? That's a good question. I think that in the future, we are looking to make that enabled by default. Similarly with the daemon. The daemon, we started out, that was an opt-in. Now it's an opt-out. So the same with the build cache eventually. You know, it's a fairly new-ish product, and that's why. Sure. The question is there any documentation for how to integrate annotation processors with the incremental build system? The answer is yes. One of the slides when I talked about that had a link right to that. So if you go to my, I'll post this on Twitter later, you'll see that. Yeah, sorry. Are there any more questions? I'll be here afterwards, and of course you can come to our booth after the talk, and I'll be happy to talk to you. Thank you.